All right, class, there's a couple of examples, a couple things I want to do that I didn't necessarily address yesterday. So let's first do something like this. Cosine of maybe arctangent of, let's go with 6/8. So you'll notice that 6/8, maybe even I'll do 9, it's negative 6/8. 6/8 is not, are not sides of one of our special right triangles. So what you would do in this case, we know it's because it's negative and tangent, for arctangent, we're only considering quadrants 1 and 4. Because it's negative, we're going to go to quadrant 4. We're going to draw an angle, doesn't have to be to scale, but draw a segment, connect it vertically to your x-axis. We have a right triangle there. The reference angle is our theta. We don't know what that is, but we do know, since it's arctangent, this is opposite over adjacent. So your opposite side is 6, and it would be negative because it's below the axis. Our adjacent leg is 8. That would be positive. And so we would want to do Pythagorean theorem or recognize your Pythagorean triples to figure out the hypotenuse. 3, 4, 5 is a special right triangle. These are doubled, so 6, 8, 10. But you could also do Pythagorean theorem. You don't have to worry about the negative, but you could solve this. 36 and 64, add to 100. So C would have to be 10. So we got our hypotenuse of 10. Now we can do cosine of this triangle. We don't have to know the angle. We don't have to, it's not asking us what the angle is. So we can just simply do cosine of this triangle. Cosine is adjacent over hypotenuse. Go ahead and simplify it. 4/5 would be our answer. So that's one type of problem that shows up on here. They're not all special right triangles. And on the worksheet that you already have, questions 1 through 12, you should not be using calculators on those. You won't get to use calculators on the quiz for that type of problem. So keep that in mind. Just draw your pictures like we just did here. Another issue that pops up that I kind of misspoke, and I told you that if you have a 0 or a 1, that means it's a quadrantal. That's not the case with tangent. Let's consider arctangent of 1, for example. We know that tangent is opposite over adjacent. And so 1, if we wrote 1 as a fraction, would be 1/1. It is completely feasible to have an opposite and an adjacent leg of 1. That's actually a 45, 45, 90 triangle. So if that's a positive, it's in the first quadrant, where our opposite is 1, our adjacent is 1. We're looking at a 45-degree angle. So we would have had 45 and pi over 4 as our answers to that problem. So I don't want to mislead you. If it's sine and cosine and you have a 0 or a 1, it will be a quadrantal. If it's arctangent, you'll have quadrantals at 0 and at undefined. Because remember tangent is opposite over adjacent, opposite over, or y over x is what I'm trying to get at. Tangent is y over x. If you think about your quadrantals, at 0 degrees or 2 pi, you would have 0 over 1 equals 0. So tangent of 2 pi or 360, whatever you want to call it, is 0 there. At 90 degrees, y over x, 1 over 0 is undefined. So tangent of 90 degrees or pi over 2 is undefined. At pi, you get 0 over -1, which is 0 again. And down here, we're going to have 0, -1. So -1 over 0 is undefined. So in order for tangent to be a quadrantal, you're looking for 0 or undefined. So like 1, like this last problem, right here, that wasn't an issue. On a cosine and a sine, that would put you at a quadrantal, but not on tangent. So I wanted to clarify that because there's a problem like that on your worksheet, and you might have been tempted to think it was a quadrantal when it's not. All right, good luck.